Today we're going to be talking about how we can write quadratic functions and models when we're given information. Instead of taking the equation and graphing it and finding out some values, we're going to go in the opposite direction. We're going to be given some values, given some points on a graph, and use that information to find the equation of that specific quadratic function. Remember, we have three forms of a quadratic function. We have vertex form, intercept form, and standard form. And what we're going to do is look at the different ways we need to approach those problems. So with vertex form, remember that vertex form is y equals a times x minus h squared plus k, where h and k are the vertex. So what we're going to do is we're going to solve this example 1 down here while looking at the steps. So I'm going to just write this down here again so we can refer to it easier. So the first thing we're going to do is we're going to substitute values of the vertex in for h and k. That means we need to look at our graph over here and see where the vertex is. Okay, our vertex, we have h and we have k. Now that probably wasn't a good choice. And k. Now we look at the point. We have another point on this graph that we can substitute x and y. So let's highlight again. See, we have x and we have y. And you'll notice that the only thing I don't have highlighted is that missing a value. So we're going to solve for that missing a value. We can go ahead and do that. So we have 5 equals a times 0 minus negative 2, so plus 2 squared, minus 3. All right, so let's simplify this. 5 equals a times, well, 0 plus 2 is 2. 2 squared is 4, minus 3. Okay, then when we add 3 to both sides, we get 8 equals 4a. Divide both sides by 4, and a is equal to 2. Now, we are not done at this point. Yes, we found that missing a value, but remember the problem is asking us to write this equation in vertex form. So now we have to go over here. Y equals our a value that we calculated was 2. And when we write the equation, you need to remember that x and y remain variables. So x minus h, which again was negative 2. So we make it a plus 2 in the parentheses, and then minus 3. So this is the equation for this graph shown here. So what we did was we took our h and k value for the vertex, we took an x and y value from the point they gave us, and then we plugged that in to the vertex form and solved for a. What you could always do is you could double check your answer here. You could graph this in your calculator and see if you plug in 0 for x, do you get 5 for y? So I guess I can show you what that looks like real quick. All right, let's turn this on. So 2 parentheses x plus 2 close parentheses squared minus 3. So now when I trace, I hit the trace button, and you see when I type in 0, the y value is 5. So I'm confident that this is the correct answer now. All right, now let's look at writing a quadratic in intercept form. So remember, intercept form, x minus p times x minus q. And in this problem, what students will often make is a mistake they'll make is using these y values as our point. We want to use those x-intercepts for our p and q value, and then use this as our point down here. So again, we're going to look at the instructions. So substitute the values of the intercepts in for p and q. And then substitute the values of the other point for x and y. So let's do that. So we're going to have negative 4 equals a times x. Well, x is negative 2 minus p. It doesn't matter which one you put first, negative 3 or positive 2. So we'll do negative 3, negative 2 minus negative 3. And then x again, and minus 2. And a lot of people also make the mistake in saying, well, I already put x in right here. I already put x equals negative 2. What x do I put in there? Well, remember, when you're writing a function, evaluating a function, that's when you plug in x for all the x's in that function. So it doesn't matter if I have 2, 3, 13, 55 x's in my function. I always will evaluate it by plugging in the same number for all the x's. So now we can go over and solve this. So negative 4 equals a times, those change to pluses, so negative 2 plus 3 is 1. Negative 2 times negative 2, negative 2 minus 2 is negative 4. Negative 4 equals negative 4a. And when you divide both sides by negative 4, a is equal to 1. So we solve for that missing a value. And remember, x and y will remain variables when we rewrite this. So y equals 1. And you don't have to write that invisible 1. You can if you want. X minus negative 3, so x plus 3. X minus 2. And we're done. And again, like I said before, you could get out your graphing calculator and double check by plugging in negative 2 for x and see if you get negative 4 for y in this equation here. So far, it has been using the correct form of the quadratic and plugging in the information that I gave you. So it's very important, if I'm saying we're in intercept form, that we use intercept form here. If I say vertex form, you got to use vertex form from up here. So what I want you guys to do is I want you to pause the video and try these. You have one in intercept form, so it's like the last one we just did, and one in vertex form, like the first one we did. So give this a pause, go back and review something if you need to, but once you're done, unpause it, and we can see if we got the same answers. All right, so here are the answers. So hopefully these are the solutions that you got for the two equations. You can see my work for both of them and how I got the answers. Again, it's very easy to plug in the correct values in the wrong spot. So just make sure you're being careful. I like to use a highlighter for the first few times just so everything gets placed in the correct spot. The last one was with standard form. And remember, standard form is y equals ax squared plus bx plus c. You'll notice that we have a, b, and c to solve for. And there is a way to do this by hand. but it's a long and tedious process, and we now have technology that assists us in this. So we're going to be using that that technology, our graphing calculators. So what we're going to do, and again, the directions are right here. We want to do detached window. So when we turn on the calculator, we want to press the stat button, which is to the right of the variables that we've been pressing. And then we're going to go to edit. And what we're going to do is we're going to put these 3 points into our list. And how you do that is all the x values will go into L1. So negative 2, 0, 2. And for the y values, -6, +6, and 2. The biggest mistake people make when we're doing this is mix matching your x's and y's in your list 1 and list 2. If -2 is your first entry in L1, then the corresponding y value, or in this case -6, must be the first entry in L2. It doesn't have to be in the same order. I could have put 0, 6 first, and we would still get the same answer. I just like going in the order that I'm given the points, especially since I put in my L1 first and then I go back and do L2. It just makes it easier for me. So now what we're going to do is we're going to press the stat button. So the screen again, go over to calc. And down here you see quad reg. That stands for quadratic regression. I'm going to hit enter. All this should be okay. What I like to do is I like to store the regression. This part is optional. Okay. And I'll show you why I do that in a minute. And then calculate. So you see it says ax squared plus bx plus c, and it gives us our a, b, and c values. So that means my equation is going to be y equals -2x squared plus 2x plus 6. And that's our answer. Now, that optional step I did, where I stored that equation, now if I look at y equals, do you see there's an equation in there? What I told the calculator to do was to take that equation and graph it for me. And this allows me to check my answer a lot quicker. So if I press trace, look at 0, 6, that's 1 point. 2, 2 is another point. And -2, -6 is a point. You don't have to do that part. You could go back here and do -2x squared plus 2x plus 6. And the same thing will happen. It's just while I'm in that screen, I might as well just do it. And you don't have to check your work. I just think it's useful. Why not? If you have the option, if you have the tools in front of you, just do it. Right, now this example here, I know it says solo, and I would normally want you to do it on your own, but just in case, I want to go through these steps again. So stat, edit, and then I'm going to put -7, -3, and +5. So all of those x values. Then for the y values, -92, -12, -44. So that's good. Stat, go over, go down to quad regression. And again, I just like to do this extra step. And we'll calculate. And there is our equation. I'm not going to go through and check it like I did on the other one because you guys get the idea. So we have y equals, it was negative 2 x squared plus 0x plus 6. Now, we've talked about this before, that 0x, we don't need to write that. 0 times anything is just 0. So this will be our final equation. This last equation down here, we have a lot more points. And let's look at how to do this in the calculator. So I'm going to go to Stat and Edit. $10, $15. And the directions for part A ask us to create a scatter plot on our calculator. I'm going to show you guys how to do that as well. So we have 10, 15, 24, 34, 45, 48, 58, 64. And then go over here and fix these y values. 115.6, 157.2, 220.8, 269.2, 285. Okay, so we have all our data in, because sometimes you don't know, is this a quadratic model? Could it be a linear model, or could it be something else? So you want to get an idea of what this data looks like. So I'm going to go to y equals, clear everything in here. Up here, I'm going to go to plot and hit enter. What that will allow us to do is allows us to graph this, and then we're going to press zoom, and we want to go down to zoom stat. And what that automatically does is that adjusts our window to fit all of our data. So this is only showing us quadrant 1. And you can see from our dots that this is pretty parabolic. We can kind of see where our vertex might be. Our graph goes up and then it comes down. So this is going to be a quadratic regression. Why would we use quadratic regression for this data? Because of the shape of the graph. The shape of the data, I should say. What sign will our A value have? Because this opens downwards, it will be negative. Find a quadratic model that represents this data. Okay, so that's when we go and say stat. We go to calculate, and we go down to quadratic regression. I'm going to store this in Y1. So you notice we just have a bunch of decimals with it too, so we should write these down carefully. Negative 0.178, so y equals negative 0.178 x squared plus 14.65. I should be consistent and do 2 decimals, so let's make this just negative 0.18. And then minus 20.15. Letter D says the left field fence is 270 feet from home plate. At what angle or angles to the nearest tenth of a degree will the ball be hit past the left field fence? So what we need to do is we need to now look at some graphs. Let's go back to y equals. go up here and press enter on plot to turn that off. I have my equation stored in y1 from before, and y2, I'm going to type in 270 and see where we cross. We have two intersection points here. I'm going to do second trace, go down to intersect, and you want to move the cursor close to the intersection point and click 3 times. And this is saying that when x is 32.92, the y value will be 270. So that's one of our answers, because you see we have two intersection points. So x equals 32.91 degrees. And now to find the other one, do the same thing, but we're going to move over to the next intersection point. So I'm hoping that you are seeing that what we're doing today is not computationally difficult. 49.71. We didn't learn new math. We learned how to use some new tools. So you may have to go and practice some of these steps on how to use the graphing calculator to get our regression data for standard form from a table. Up here, we just simply plugged in some values, simplified to get our A value, and plug that back in. The calculator part does take some time to master. So if you need to review some of these things, that is no problem at all. So thank you for watching. Make sure to like this video and subscribe.